astronomers of Unimatriculation Higher Secondary School, Salem from Tamil Nadu, have found a problem and a solution which is prevailing in our society: water pollution, which is caused by industrial activities such as dye, textile, and paper industries, which releases synthetic dyes and makes the water non-biodegradable wastewater, which affects the aquatic life and human health. To address this issue, we have found a chemical dye filtration system which filters the water and gives a purified form of water to the society, and it doesn't harm the aquatic life and human health.
Why this project? Untreated water affects the water bodies, aquatic organisms, in turn human beings. So it's time to find a new solution for this problem. Here is what we have done.
Let me share about this project. This project works in the adsorption technology, which has the activated carbon as its main component, which absorbs the dye molecules and gives the purified water before discharge or reuse.
So we have created this prototype. This filtration system consists of several components. The main components are as follows. First, the inlet tube. This is the entry point for the contaminated water to get into the filtration system. Then it passes through a top cotton pad, which prevents most of the solid dust particles from the water. Then it passes through an activated carbon layer, which captures impurities, chemicals, and odors from the water. Then it passes through a fine sand layer, which captures suspended solid layers. Then it passes through a gravel layer. Its primary function is to pass the water throughout the filtration system at a consistent rate and prevent clogging. At last, it passes through a bottom cotton pad, and its primary function is to prevent the loss of filter media like gravel and sand. At last, we can collect the treated water through the outlet tube, and now the water has been purified.
Working principle: the water enters from the inlet tube. Later, it passes downward to top cotton pad, sand layer, and gravel layer. All these layers help us to filter the suspended solid. Later, the water goes down to the activated carbon layer, which traps the dye molecule in its porous layer. Another layer of cotton is pressed to again prevent the suspended solid to not be get filtered. The water is now collected in the outlet funnel. Uses and application: it can be used in many industries such as paper, plastic, and textile industry. It can be used as project in environmental programs to create awareness, and etc. etc.
Advantages of our projects: low cost. Material used in these are sand, gravel, and charcoal, which are easily available. Simple design. It's easy to assemble and need of no electricity. Eco-friendly. Charcoal and biochar are biodegradable. Scalable. Can be scaled in industries and small setup. Effective dye removal. It removes visible color and toxic chemicals. Reusable filter media. Activated carbon can be regenerated by chemical washing or heat.
Let me share the future scope of our project. This can be still advanced by incorporating the photocatalyst, for example, titanium oxide, which degrade dyes rather than just absorbing them, and integrating sensor systems. For example, in the filters, if we insert the sensor systems, it will check the water quality automatically. Developing the modular filter units will be useful for the small-scale industries. At last, we conclude our collaborative work by saying that this chemical dye filtration system is a low-cost and efficient filtration system. This is a combination of traditional filtration as well as the adsorption technology, which purifies the water and saves our environment from the water pollution. Signing off from you is